Good evening. You nearly made it, and they also made it. So this was tough, but now, today, short before we have the dinner session, we want to speak with you about speed and about success. And the unique process that we have found out that it needs in order to secure this. A unique process of collaboration. Now we are here at this AM forum. It's about additive manufacturing. Why do we speak about collaboration? Because we believe, and in hundreds of projects, we found out that this is the real missing link to connect all these existing good technologies and good approaches to derive one really working, scalable solution. And these additive manufacturing solutions, we also believe, are the missing link for our industries to be able to cope with the necessary transition that they are going through. So, collaboration is the key for us to continue with our industrial valves that we have. Now, what is the difference between bringing to market a new product in a traditional way, like with injection molding, or with additive manufacturing? Now we see that in a traditional situation, you have just a wealth of well-developed norms, specifications, experience, and so on. So basing on that, it's totally sufficient to have a customer-supplier relationship. You still can rely to get your part. It's safe, but it's sequential. It's slow. Now, time is of essence in our transitions, and therefore, we want to work with additive manufacturing. But does this then work in this kind of setup? We do not have this wealth of norms and experience and so on in additive manufacturing. We need to have a different setup. It does not work this way. So we need to have a unique, different way of collaboration. In order to achieve this speed that we still want, we need to align our specifications that many times are derived from the traditional manufacturing methods and not purely from the purpose of the parts. We need to align them with those materials that work with additive manufacturing and the processes that we have, how to come to a design for additive, printing, post-processing, workflow. So, and this, to be aligned, derives at the end the value of a solution. The value is in the alignment of all of these aspects. And when we look back, all of the successful applications that we see today as a standard in additive manufacturing, they all have gone through that triangle. So, applying this learning systematically will lead to systematically successful projects. And we want to give you an example for this today. We have this wonderful company with these bikes, Canyon. And Dominik, you came to us with the idea of this computer mount that we have here. This is not just a computer mount. This is a really critical part. Because the driver of this bike, he is in real time controlling his heartbeat, his watts that he's driving, and so on, and he is a super performer, so he knows that very well. And when he cannot read the numbers, he has a problem. And he would run this bike through the toughest conditions that you can imagine. So this needed to be fixed. And this is a very typical example that we find ourselves many times in, because we work with nearly every machine maker that there is, and we work with many customers, and we love to work with Canyon too. So And many times we found ourselves in a situation that we drive this alignment process, which we love to do. And here in this collaboration, we propose then to close this triangle with a production partner who is RPM, a long-lasting partner of ours. And we know that they have the necessary experience and capabilities. We built together an agile project team, and we're working interdisciplinary, agile, together to derive these needed performance parameters. We took on the challenge. And what was the challenge? So, 2 clear challenges. First, redesigning this mount to meet all these tough conditions that I mentioned. And second, to scale up a production that can adapt to the customer demand on a short time frame, on a really short time frame. And you will learn about that later. So now, this is the moment where I would like to hand over to you, Dominik.
Thank you, Martin. Till now, we sold about 3,500 of these computer mounts. After development and testing, we even went through wind tunnel testing to see if this computer mount is also aerodynamically okay. We had approximately 4 months to market because we linked this product to a launch of a bicycle. We reduced the weight to 17 grams and used BA11 with carbon fiber reinforced from BASF. We currently have 2 versions, one for Garmin, one for Wahoo. For some of you, this might be an information which is not so graspable. These are the 2 main computer manufacturers we support on that. Something about Canyon. Currently, we have almost 1,500 employees. We are based in Koblenz. Last year's revenue was about 650 million. We make bikes for some of the toughest racing conditions. Elite cyclists choose our bikes because precision matters. Every aspect of the development of our bikes and accessories must meet high standards and tight constraints. Something about this race, this computer mount needed to perform is Paris-Roubaix. Some of you might know that. That's one of the biggest spring classics. It's a monument. It's 280 kilometers long and has 55 kilometers of one of the toughest cobblestones. And that's why it has the nickname, the Hell of the North. Matthew van der Poel wins this monument this spring in an epic speed record of 46.8, as I mentioned, on 280 kilometers. That's quite insane. The computer mount performed as it should, so the calculations were perfect. It kept the vibrations at bay, and Matthew could launch the last attack with a clear view on his data. What were the requirements? We started the project with the following requirements. It was important to use vibrations, as we mentioned. Then also we reduced the weight. The computer mount in a classic injected way had 50% more weight, and also the strength in warm as in cold weather conditions was very important, but also the durability of the part was important. BASF Forward AM was helping us developing a very strong structure which would keep these boundaries we gave them in place, basically. Then you see getting the right look and feel. Of course, 3D printed parts, everyone knows that. It's not always easy to bring it to a sellable product. We did here several steps from the more organic look and feel of the most left part to even integrating the clicking mechanism where the computer clicks into the 3D part. This was very important that the part meets our Canyon CI, especially on surface finishing, that you see here the bike has a lot of shiny matte surfaces, that the computer mount wouldn't be like a foreign object to the whole bike assembly. And this brings me to Brian.
Yeah.
There you go.
Thank you. Because we got what was a perfectly simulated and a perfectly designed part, but there was still one problem, is that it had to be manufactured. And that's why I think BASF chose an important part. You see here, they came to a contract manufacturer. So RPM has been working with SLS, 3D printing in particular, for 26 years. But after about 10 years, we started working in manufacturing of series parts in our other casting technologies. So polyurethane casting, nylon mold, rim, injection molding. And like Martin mentioned at the beginning, these types of ways that we're approaching projects, understanding what are the norms, what are the tolerances we need to hit, and making sure that we're bringing those back into our process was really the key to actually making a successful part come out the door. And something that's not to be underestimated. We even actually, for this project, we're taking people that are trained for doing our quality assurance for these series parts and bringing in these processes into the additive manufacturing standards in direct collaboration with BASF to make sure that those are working. Not to be underestimated. Nope. Because we mentioned that the project was going for 4 months, but by the time we had everything locked down and we were getting ready to go into series, we had then 6 weeks left. That included making the last design optimizations. So one thing that everybody's heard about is design for additive, but what we did is take it one more step further, which is design for repeatability, design for production. So it's everything, like Dominik mentioned, doing a series of different testing, so we're making sure that we're getting exactly the surface quality that we need, because this is a consumer-facing consumer part with a highly visible piece there that needs to match. It's also things where are we hanging the part for chemical smoothing, how are we making sure that all of the edges are cleaned when we're moving it, very mundane details. And only by having a direct collaboration with someone that knows over the time what to look for and really working hand in hand to do these iterations with Canyon allowed us to hit that mark. The next piece, not to underestimate, is that we were doing a test launch, essentially, of this project. This was for Canyon, a big step forward. We agreed to a series pricing, because these are parts that are going out in the consumer market on 1,000 parts. You heard we're now 3,500 sold and more already produced. But at the point, there was no guarantee. So from RPM, we were going into a certain risk. For Canyon, also a certain risk to make sure that we're getting out. And you see 500 and 500 because we're doing 2 designs in a single process, which means that we're saving all of those tooling costs. And the last piece, not to underestimate, is that these were going direct to consumer. So Canyon is not sold in a bike shop. They get the parts and they send them out, which means that we were not only printing and finishing the parts, but also printing and finishing approved packaging, putting them all in and shipping them out on big containers so that Canyon can give them out to the customers. So this is why working with a contract manufacturer in this mentality is so important, and also where we think that the additive industry needs to continue to move over the next years, to thinking about in a full process and what are the full needs of the customer, and not only how are we getting parts out the door. What do we as RPM bring to the table? That's repeatability at scale. So we're talking about a lot of different steps. Machines everybody can buy, but the piece that's important is the documentation and locked production parameters. Because in the same process that we are finishing the design, we are also locking everything that we were doing for actually doing the production, so we have that repeatable quality. Because we're producing now 1.5 years or so, and every part that comes out, every batch that comes out, needs to be making the high quality standards of the parts. Why do you come to somebody with experience? Where do you need to be looking and choosing really smart partners? One is that, and that's not only the first step, but we are also doing, like you know from injection molding and other processes, ongoing quality assurance, looking for the failure analysis and making sure that we're improving continually over time and also for future projects. We were doing this design and series optimization in parallel. That's the collaboration that Martin spoke about at the beginning. So we are sometimes hourly adjusting the designs to make sure that things were getting ready for the production that we needed. And also the long-year relationship with BASF, because we knew who the technical contacts were, we knew what we needed to do with the materials to make sure that we are bringing the part over the finish line successfully to launch this project out into the world. Martin will close up.
Thank you. So to wrap up, what are the superpowers that were put on the table in order to make this possible? So first of all, as you heard, an agile project team that really wants to work together in an interdisciplinary way, where all were committed to join forces and to put themselves behind the common target. This is not evident. This is not every time the case. But in this case, this was the case. And this was a major reason for the success. So also, of course, deep knowledge of the individual areas and the flexibility of Dominik and the team also to adapt design to the better. And putting all this together made us becoming a strong team until to develop this solution together. Why does this matter to us as BASF Forward AM? Today we are the only independent global full portfolio provider for additive manufacturing materials and solutions. And therefore, we are connected with nearly every machine maker in the world, but also with many, many customers. And many times, we are put in this role. And sometimes it works, and sometimes not. So it is our deepest interest for us, but also for this economy, for us as an ecosystem, but also for our industries, that this kind of successful method of working together becomes a standard. We need to make this collaboration better in order to make these solutions to succeed more and becoming stable, repeatable, and trustful solutions for us to grow. We have understood this pattern of success, and this is what we want to roll out. And therefore, we have set ourselves in our organization accordingly, and we have built a team with these superpowers. Because we see that basically wherever we join such a team, we create a new solution in additive manufacturing. And there's a whole blue ocean out there. We are only 0.5% of the whole manufacturing industry, right? So imagine how much more there is to discover when we do it right. For the sake of our industries, but also for the sake of creating sustainability solutions, more sustainable solutions than we have today. We spoke of digital warehouses today, and so on. So we have set up a team of really heroes with superpowers, as you see here, on simulation, on workflow, on software that combines things, engineering and design. And as we thought at the beginning, this is about speed, about freedom of design and local production. So we showed today one amazing example of how we can collaborate better and what we as companies can deliver when we do it right. We have delivered a wonderful impact for professional cyclists in the toughest conditions in the world. And we are ready to unlock innovation together with you.